So whilst they're doing that, have a look at the example on slide 36. Okay? So on slide 36, we've been given a normal distribution. So x is a random variable that's normally distributed with a mean of 5 and a variance of 3 squared. Okay? And we've been asked to find the probability that x is less than 1. Okay? So first things first, this thing is not a standard normal distribution. Okay? Because its mean is 5, and then each step is basically worth 3. So it goes 5, and then if I move in the other direction, it goes 8, then 11, then 14, and in the other direction it goes 2, -1, -4. Does that make sense? It's literally the same kind of thing as that. So the first thing that I need to do is I need to standardize. I need to make sure that this thing follows a standard normal distribution. In other words, the center, the mean is 0, and then each step is basically just 1. And I do that using this process here. Okay? So here I would say z would be equal to x minus my mean, which is 5, all divided by my standard deviation, which is 3. So I'm literally just following this formula here. Question is, what goes here? Exactly. It's the outcome that I'm interested in. So the outcome I'm interested in this case is 1. Isn't it? The outcome I'm interested in is 1. So in other words, the outcome, which is x, is going to be 1. Okay? So I'm going to basically see, if I take 1 and I standardize this distribution, where will 1 now end up? That's literally the question I'm asking. So if I look at 1, wherever that is on the distribution, in fact, let me draw this normal distribution out. So it goes 5, 8, 11, 14, and then 2, -1, and -4. Okay. At the moment, 1 is, where is it? It's about there, right? You happy with that? That's where 1 currently is. I basically want to see where 1 ends up when I standardize this distribution. In other words, when I convert it to a distribution with 0, 1, 2, and 3, and -1, -2, and -3, my question is, where does this value now end up? Okay, that's what I'm after. Does that make sense? Okay, and I can do that using the standardization process. Because this standardization process takes every single value and transforms it to where it would end up on the normal distribution. So if I just want to take 1, I take away 5, divide by 3, that should tell me what my standardized value is going to be. So in this case, 1 minus 5 is -4, divided by 3, that's about -1 1/3, so -1.33. Is that okay? So in other words, where it ends up, so it was here, x equals 1, is going to be z equals -1.33. And you're probably like, well, how does that help? How do I find that probability? Well, now what I'm effectively trying to find, if I have this distribution, so z is normally distributed with a mean of 0 and a variance of 1, okay? I'm basically now asking not to find the probability that x is less than 1, but find the probability that z is less than...
-1.
Exactly, that's my new value. Does that make sense?
Yes.
Yeah, that's my new value. So the question is, well, how do I find that probability? How do I find that probability?
We have a table.
We have a table to do that. Okay? So I'd really want to show you where those tables come from. If you have a look, I'm not too worried about it because it's in the slides. Okay? So if you have a look at slide 37, did you manage to get it mirrored to your screen or not?
No.
Okay, that's fine. That's fine. Okay, so if you have a look at slide 37, you have these things called the tables. Okay. Now, the way which the tables work is all tables, all the continuous random variable tables, the tables which are in that document, are all continuous. Okay, so they're all cumulative, right? So in other words, if you want to find the probability which is in this table is everything less than or equal to that value. Okay, so if I look in the table at -2, it'll be everything less than -2, not greater than. Okay, so it's everything less than. So all these values here are all cumulative. They are all less than or equal to. They're all less than or equal to. Okay, so if I'm trying to find -1.33, the way which it would work, if you notice that column on the left-hand side is all the values that you start with. So they're all -1.3 in this case. Does that make sense on slide 37? Yes, you've got negative 1.3 along the left-hand side. Now what you're after is negative 1.33. So you go down to where you hit the negative 1.3. So you go down to the row which starts with negative 1.3. You all there? Yeah. Okay? Okay, exactly. And then basically you move your way across. And the way which you move your way across is according to that second decimal place. Okay? So if you want negative 1.33, you're going to have to move across until you hit that 0.03 column. Does that make sense? Yes. Yeah, so you will see that. So what is that probability? Can somebody tell me?
0.9.
What is it, sorry?
0.0918.
0.0918. Okay. 0.0918. Okay. Now, what I always tend to do is convert this into a percentage, just because that doesn't really mean anything to me. Okay. So this would be 9.18%. Okay. So in other words, if I have this normal distribution with a mean of 5 and a standard deviation of 3, the probability that I obtain a value which is smaller than 1 is equal to 9.18%. Does that make sense to everyone? Okay. Now I said that all of these tables are cumulative. All of these tables are cumulative. What if it was greater than or equal to? So what if I didn't want the probability that x is less than 1, but the probability that x is greater than 1?
1 minus.
Absolutely. Just use the fact that everything underneath the curve has to add up to 100%. So if I'm looking at everything up to that point, but I actually want everything beyond that point, I just do 100% minus that probability.
Minus 9.18.
Absolutely. That makes sense, right? Because everything up to this point is 9.18%. If I want everything greater than that point, I'm just going to do 100% minus that probability. Aren't I? So 1 minus 9.18. Or 100% minus 9.18%. Is that okay with everyone? Yeah? I can even do fancy things like looking between two values. They've done examples of those in the slides as well. Okay? But what I really want to make sure with everyone, and it's such a shame that I can't share, although it might share, I don't know. I can see we're trying. What I would really like to do is show you how this works like on the screen, because I think it would be a little bit clearer. But is everybody roughly okay with using those tables? Yeah. Okay? So in other words, when you're looking for a value, once you've standardised and you're looking for a value, just make sure it's always less than. Once you're looking for that value, you go down to the row, and the row is always the first two figures. Okay? So in this case, I'm looking at the negative 1.3 row. And then how far I move across is determined by that second decimal place. So in other words, when you standardise your value, you always want to leave it to 2 decimal places. Is that okay?
Okay.
Good.
Do you round it?
Yes, exactly.
Okay.
So always to 2 decimal places. Because in the tables that I've given you, you only have 2 decimal places of accuracy anyway. Okay. There are some tables with more decimal places of accuracy, but in the tables which I've given you, which you're going to get familiar with, there's only 2 decimal places of accuracy.